Okay, students. So now we are going to observe what happens to a beam of light, a parallel beam of light that passes through a biconvex lens. So here I have a biconvex lens. You can see the two sides or the surfaces are curved outwards. So that is a biconvex lens. So this is what I am going to use now. And here in your activity, you are supposed to use a comb and get a parallel beam from the sunlight. Pass it through the comb so that you get different rays of light. Or else you can use a torch and a comb again to get a parallel beam of light. But here I am going to use a laser beam. You can see here it gives a parallel beam of light. So that will be easy for me to demonstrate the activity. So now that we have a parallel beam of light, what I have to do is I have to keep the biconvex lens in between. So the beam passes through the biconvex lens and you can see what happens here. So here students, you all can see initially it is a parallel beam of light. When it passes through the biconvex lens, they all meet at one point and that point is known as the focal point. So here, because the rays all go towards each other, we call it a converging beam. So a parallel beam becomes a converging beam and they converge onto one point, that is the focal point. And the distance between the lens and this focal point will be the focal length. Okay, students. So you were able to observe how a parallel beam of light, that is the laser light, was converged by a biconvex lens. And all the light rays converge through one point. And what did we call that? That is the focal point. Okay, students. So now we are going to observe how a beam of light, again a parallel beam of light, I told you all in the previous activity also, you can use the sunlight, pass it through a comb so that you see the rays separately. Or we can use a torchlight to obtain a parallel beam of light. Here I am going to use a laser. This also gives a parallel beam of light. You can see the rays parallel to each other. And at the same time, I have this biconcave lens. You can see both the surfaces are curved inwards. A biconcave lens. So what I will do is, I will place it here. Now you can see what happens to the rays. So here you can observe clearly the parallel beam of light coming from the laser light and they are getting diverged. You can see them going away from each other clearly. And as I told you, when you extrapolate, that is when the same rays, when you draw it longer, here you can see between the laser source and the lens, there is a point where all the rays are going through and meeting each other. They intersect each other. That is the focal point of a biconcave lens. Now maybe you will be able to observe it a little more clearly when I move the lens. It is a bit faint, but still you can observe a spot near the laser light where all the beams meet or intersect. So from this you can understand that a biconcave lens diverges a parallel beam of light. Okay, students. So now we are going to observe how an image is formed by a biconvex lens. So here you can see both sides are curved outwards. You are familiar with the biconvex lens. And here I have a stand. I will fix it to the stand. And although the stand is here, to identify the position of the lens, we have a mark there. So when I am moving it around and also to measure the distance, it will be easy for us. Then we have a screen. This is the screen that I am going to use and a measuring ruler so that we can measure the distance between the lens and the image once it forms on the screen. So first I am going to focus or get the image of an object that is far away, something that is outside the window. So to do that, first I will place the ruler, then I can adjust the lens so that you will be able to, now you are getting an image. I will make it to 0 position. You are getting an image, but it's not very clear yet. So we have to make it clear so that we can see it properly. I have to adjust the lens so that you get it clearly. So now here you can see the image of a plant. So that is a far away object, a distant object. And if we take the proper measurement, you can see here it's very sharp image. So at that point, if you look at the reading or the measurement, the length between the lens and the screen, it's 9 centimeters. So this is an object that is far away from us. And we have got the image on the screen, and the distance between the image and the lens is 9 centimeters. After that, I will need another object, that is the candle. So I have to use a lighted candle. So now I am going to use a close by object. For that I am going to use the candle flame, a lighted candle. So here if I have it at that same position, 9 centimeters, you can only see the far away image. You can't see the image of the candle. So here the candle is a little taller. So what I will do is I will lift the lens as well. So now with that, if I move the lens a little bit more, so I am going to move the candle a little bit more so that we get a more better image. You can see a little bit more clear image now. So still the object is closer to us, closer than the previous object, but you can see the distance between the screen and the lens. Now it is 19 centimeters. So earlier when the object was far away, the image distance was 9.5 centimeters. Now when the object is closer to the lens, the image distance is 19 centimeters. So when the object is far, image distance is short. When the object is close, the image distance increases. So that is what we can observe from this activity. Okay students, so you all know we need to observe close objects and far objects. And to observe that, we need to have convex lenses with different curvatures. That is what we are going to observe now. So here I have two convex lenses, one with less curvature and the other one with high curvature. So now what I am going to do is, first I'll use the lens with less curvature. I will place it on the lens holder and try to focus an object that is far away. Now can you all see the image of a leaf there, a part of a tree? You can see the image of the leaf. That is a clear image. When I position it somewhere here, you can see the images. At this point, you all can see a clear image of the leaf. So a far object with a thin lens, that is a lens with less curvature, we can get a clear image. So now at the same time, you all can see there is no clear image of the candle on the screen. Now I am going to change the lens. Now I am using a lens with higher curvature. Now here students, you can see the candle is a close object and you can see the image of the candle clearly. But you can't see the image of the far object clearly. So from this observation, you all can understand to observe a far object, we need to have a lens with less curvature. Whereas to observe an object that is close, a close object, we need to have a lens with high curvature. So inside our eye, the distance between the retina, that is the screen, and the lens cannot be changed. So the image distance is fixed. But when the object distance changes, the lens of the eye changes its curvature to observe that object. That is what we can understand from this activity. Okay, students. So now we are going to observe how we can correct the long sight. So to correct long sight, we need to use a biconvex lens. So already I have a biconvex lens here. You all can see I have set it so that we can get the clear image of a faraway object on the screen. Can you all see the image here? It's clear. But you can see the image of the candle is not clear. So now what do we do? So we can see far objects, the far away the tree clearly, but the close object, the candle, cannot be seen clearly. So if we hold a biconvex lens, now this is the lens of our eye, this is the lens that will be there in the spectacles. So when I hold it here, now can you all see the clear image of the flame there? Without this, you can't see it. Now with this, you can get the clear image. So that is how we correct long sight. So now students, we are going to observe how we can correct short sight. When we say short sight, you can observe close objects. So we should be able to observe this candle clearly. Now let me adjust. Now this is the lens of our eye. With that, I will make the position of the candle clear. Can you all see the image of the candle on the screen? Is it clear? Yes, we can see it. But we cannot see at this part, you can see the image of a faraway object, but that is not clear to us. If I use a biconcave lens in front of this lens, why this is the lens of our eye, we will be wearing the spectacles. Now with this lens, can you all see the clear image of a faraway object? You can see the leaf of a tree. When I move it, it becomes blurred, but at a certain position, you can see the clear image, and that is also an inverted image. So you all can understand now when we have short sight. That is, you can see close objects, but you can't see far objects. We can use a biconcave lens in order to get a clear image. That is how short sight is correct.